Hi everyone, thank you so much for coming. This is about Team Ithaca, so I'm going to be pretty quick, I hope, but I am a professor, which means it's probably going to feel like a long time to you. But for me, it will be quite quick. So this is not done, it's not just me doing this. Andy, Alex, Anita, Laura, James, Ronaldus, Kat have all put into the science. There's also a whole team of engineers, John, who's over here with us today, and from Pulver and Harwin. So it's not just us, but I'm just going to talk a little bit about the science. It's a bit backwards, because normally we would talk about the rowing and then the science, but because the rest of the evening's about Team Ithaca, I'm just going to give you some highlights. So why are we doing this? Well, what are we doing? I thought that rowing around the UK seemed really quite easy, so I should make it much harder for people. And I've asked them to collect temperature, microplastics, sound, and eDNA while they're going around. So temperature is just a sensor, just, you know, the temperature of the water. Very important in understanding climate change. Microplastics, everybody has heard about those. They're in our waters and they're causing damage to the ecosystems and to the fish. Sound. I'm going to talk a little bit more about sound and why that's important. It's not just listening to the dolphins, but it's also listening to the sound pollution. Boats, drilling, all these kinds of things actually have an impact on the marine life around them. They can't hear each other, they get very stressed, they might not be able to find their food because of that. And eDNA, which is environmental DNA. So, of course, if you're looking at pollution, what you want to know is if it's had an impact on the species there. This is quite hard to do unless you go scuba diving and you make a note of all the species that you found. But instead, what we're doing is collecting water samples and looking at what DNA is in the sample. So if a fish swims by, it will leave some of its skin, maybe some feces in the water, and that will contain its DNA. So we can say, a cuckoo wrasse swam by here. Yeah. So I am not doing that. Kat is doing that from Naturemetrics and providing the data. So the idea is that we will put all of this together and we will start to see what is causing the problems with biodiversity. But also, along the south coast here, we have lots of rewilding projects. I don't know if you've seen, we've planted a lot of seagrass just here, down at just by Portsmouth, to help reduce the impacts of coastal flooding, but also to take carbon out of the atmosphere. In Sussex, they've got the kelp forests. They're planting kelp there to try and... So is that working? What does that have in terms of an impact for all of these things? That's why we're doing it. So here, I laughed. This is what the girls in Team Ithaca did. This is 44 days of their life in 20 seconds. See, I told you it was easy. It's fine. But this is actually the temperature data from that race. So this is what they did. So you can see that the temperature is nearing 20 degrees in the Thames. It comes round very warm for the time of year. We don't normally breach 20 degrees water temperature in this country. So it's very significant that in these areas that we're starting to see this yellowish colour, suggesting that we are getting warmer waters there. And that really has an implication for the species that live there. In terms of the microplastics, so this is, obviously this is not the UK, but these are microplastics. This is real samples taken from Indonesia. There's a huge amount of plastic entering our oceans. They reckon it's about one rubbish truck every minute is entering our oceans overall. Not all of those are microplastics, that's plastic as a whole, but that's the kind of problems that we're facing. My interest is in microplastics because obviously they're small and they get eaten. So this is a rainbow runner and it had 18 pieces of quite large plastic in its gut when it died. And this is impacting, they can't feed, they're not getting nutrition from that, so they're not very well themselves. And this is from last year's race from 2022, and these are some of the microplastics that we found in there. And you can see here, this is 200 microns, so this scale bar here is 1/5 of a millimetre. So these things are really, really small, yeah, you're not going to see them. You would look at the water and think it was clean, but it's only when you start to do this work you can tell what's happening. In terms of for people who are local, I tried to keep it local while we're here. So this is a map of microplastics around the coast. It's been stretched. There were between 0 and 121 microplastics per metre cubed. So a metre cubed, you know, this by this of water. So 121, unsurprisingly, was in the Thames. Averaged about 20 microplastics per metre cubed. So that is actually, it was 20.3 locally here, just outside the Isle of Wight. In terms of what does that mean? Like if you don't know what a metre cubed is and you don't know how big the Solent is, you know, it's really hard to get a grip to those numbers. So imagine that you were in your bath, there would be 6 pieces of plastic in it. That's what that equates to. And then if you looked at the Solent and you look about the water in the Solent, that's roughly 38 billion pieces of plastic in that area of water. That's the kind of numbers we're dealing with. So I said I'm going to talk a little bit about underwater noise. So we think about dolphins and whales, and you can see them talking to each other here. The sound travels really, really well underwater, so nearly all the species use it, whether it's for communication or defense or finding prey. Nearly all species use it in some way. But if you've got ship noise, drilling noise, all these sorts of things going on, it can interfere because they don't hear in the same sound range that we do. They hear much larger frequencies, range of frequencies, and sonar, which we can't hear, they can. And it must be giving them quite the headache. So I quite like this. I just like the picture. So what you can see, so yeah, that was absolutely. It really is that there were papers out recently last year talking about how dolphins are now having to scream to each other. They're shouting, they're, you know, to be heard when they're trying to find food, because obviously they normally forage together. And so when they try and coordinate their attacks, they can't, or they're really struggling to. So it's a really important issue, and one that people don't think about too much. In terms of the sound, this is what a dolphin looks like, and I'm hoping this should be from you guys, but I don't know if this will work. Okay. Can you hear those clicks? That is a dolphin from the south coast that came from Team Ithaca's boat. And I'm just going to give it a little bit longer because it gets quite nice at the end. They go crazy. They have a little bit of a chat with each other. So obviously you can hear the sound of the water against the keel while this is happening. Oh. And there's a few of them having a bit of a conversation there. Right, so the difference between that quite nice melodic sound, and in a minute you'll hear a boat go past. Now this is what the species are living with day in, day out. So can you hear like a noise coming? It's going to get louder and louder, and they're listening to that almost 24/7. You can see what it looks like here. This noise is whiting out. This is where they talk to each other, and this is where the boat noise is. And you can see it's interfering completely with how they would vocalize with each other. So imagine that all the time. You'd really get quite the headache. So, and finally, we haven't found this for Ithaca's team yet, but I quite like this, so I'm just going to turn this one on if I can. She says. I have to wait for that one to finish, sorry. There we go. What do you think this is? What do you think it sounds like? Popcorn. I did this with some school kids. They went sizzling sausages. So that's quite good, actually. Yeah, it's actually snapping shrimp. So these are tiny shrimp. They're about this big, and they have these claws, and they're so powerful that when they snap, it makes this incredibly loud noise. And we're able to find where they are around the coast by listening in to see them. And they seem to be moving north with the temperature rises. So that was actually from the previous year's row. We're looking for them still, in the Team Ithaca stuff. Okay. So, sorry, that was a little bit of a, I just thought I'd show you, let you listen to some of these sort of sounds. So in our local waters, what have we got? 9 out of 10 fish species in the world live in coastal waters. Our coastal waters, we think about the open ocean, we watch Blue Planet and things, and we think about the middle of the ocean. Actually, it's quite barren out there. There's still life, But in terms of the abundance of life and the number of species you find, it's really the coastal waters, the shallow waters where the light penetrates and there's lots of food. So what we did, we gave these eDNA to Nature Metrics, Kat's with us today, and they looked at these. We found 82 species in 77 litres of water. So 77 litres of water were filtered in 2022 as they went around Great Britain. And we found 82 species, and 33 of those species were here, just outside the Isle of Wight. And we have 70 samples being currently analysed for Ithaca, and I don't have the data for you yet, so later on, next year. But these are some of the pictures. These are some of the things that you have literally here on your doorstep. Dolphins, different types of wrasse, conger eels, seals, and really importantly, sand eels, because they're a keystone species, which means lots of things eat them. So if they're healthy, lots of the other species are. So whilst it can be a little bit doom and gloom with all the pollution stuff I talk about, there are hopeful signs. These things are still here, and let's work to keep them going. So what? Why am I talking to you? Why did we do all this? One of the reasons is that I'm a marine scientist, and it would cost me hundreds of thousands of pounds to go out and collect this data set, because I'd have to charter a boat and I'd have to go around and it'd be really expensive. It's free. Well, it's free for me. It's not free necessarily for the rowers who have to, like, you know, keep stopping and changing filters for me. But they're very kindly, they have done that. So it is low carbon. Instead of me emitting carbon dioxide from my boat engines, there are the rowers are going around doing this manually, and it's relatively cheap. We'll be collecting data till 2025. And as I said, the idea behind this is we're going to put all of this data together from 22, 23, 24, 25, and we're going to get a really good baseline of what's happening in the UK for all of these different parameters, and hopefully get some insights into how they're impacting each other. Are our seas getting better, or are they getting worse? My feel is it will be a mixed message. There'll be places where we've put in conservation works where they'll be getting better, but in other places it will be getting worse. And I could not do any of this without the people who went and collected the data for me. So without further ado, I will hand you over to the stars of the show, the people who actually collected the data.